So after discussing about the mass percentage, volume percentage, molality, let's talk about mole fraction. So guys, our new concentration term is mole fraction, and that is the ratio of the number of moles of one component to the sum of the number of moles present in a particular solution. So what we have to do in this case, first we have to find out the number of moles of the solute or a component, then we have to divide by the sum of the number of moles of the other components present in the solution. That's why the mole fraction is the ratio of the number of moles of one component to the total number of moles of all components. Means since we are studying about the binary solution, that's why it is written solvent and solute present in the solution. What is the formula of mole fraction? That is, if we are finding the mole fraction of the solvent that is designated by A, we will write XA. XA will be Na divided by Na plus Nb. And what is Na? Na is the number of moles of solvent. Na plus Nb is the number of moles of the solvent plus the number of moles of the solute. That is the total number of moles present in the solution. Similarly, we can find out the mole fraction of the solute, that is number of moles of solute divided by the total number of moles. One more thing I want to tell you is, if you add the mole fraction of the solute and the solvent, it will be always 1. Now let's talk about parts per million. It is the weight of the solute in grams per 10 to the power 6 grams, that is 10 lakh grams of the solution. Means the ppm, the formula can be written as Wb, the weight of solute, divided by Wb plus Wa multiplied by 10 to the power 6. So what does it mean? If we find out the weight out of the 100 gram of the solution, that will be weight by weight percentage, right? And if we are finding out the weight of the solute from 10 to the power 6 gram of the solution, that will be parts per million. And parts per million is used when the concentration is very, very less, right? Now, there is another term that is called formality. The molarity of the ionic solute is called formality. Means it is the same thing, formality F, that is equal to number of moles of solute divided by the volume of solution in liters. But in this case, this number of moles of solute, the solute will be the ionic solute, right? For example, NaCl, NaOH, etc. If we find out the molarity of glucose, in that case we can't say it formality. But if we are finding out the molarity of NaCl, NaOH, sodium carbonate or another ionic solute, in that case molarity and formality are the same thing, right? Now, in this question he is asking, what is the mole fraction of the glucose in the solution? It means that glucose is solute. If 18 gram of it is dissolved in 9 gram of water, first what we have to do, we have to find out the number of moles of both of them. So the solution will be first we have to find out the number of moles. So number of moles of glucose will be equal to its given weight is 18 and molar mass is 180, and that is equal to 0.1. So, this is the number of moles of glucose, that is solute. Now, we have to find the number of moles of the solvent. So, the number of moles of solvent, number moles of solvent is water. So, we will write and that is equal to 9 is the given weight and 18 is the molar mass of the water, and that is equal to 1 by 2, which is equal to 0.5. So, we have to find the mole fraction of glucose. That is why we will find XB, that is equal to number of moles of the solute divided by number of moles of the solute plus the number of moles of solvent, and that is equal to NB is 0.1 and it is divided by 0.1 plus 0.5 and it is divided by 0.6, that is equal to 1 by 6. And if we further solve it, we will get 0.167. So, this is the mole fraction of glucose in this particular question. Let us move on to next concentration